This is a demonstration video of building a high pressure pump package for misting. And what I have here is a box I just received from Cat Pumps. It's a pump package. It's a Model 1 CX05 that has a half a gallon a minute output. So I just received this box, and what I'm going to show you is how this pump package goes together with a few extra pieces for a customer. So this is a time-lapse photography type video, so it's fast-paced, but it shows the assembly of the pump package. I'm explain it as I move along here. So we're going to start the video, opening the box. Now the first thing that you see here is the manual is on top. Cat. One thing I like about Cat is they have very good manuals to go with the pump. So there's a service manual and a cut sheet on it, and a few other things that I page through here. So right there I'm showing you what I'm going to build as far as the pump. They show some accessories that go into a typical pump package, and that's basically what I'm doing in this particular video. So we'll continue on here. So within this pump package there's basically four, well, let's count them here. There are 5 different things. You got the manuals themselves, you have the pump here. Let's move it along here. You have the pump itself. You've got what's called a pulsation dampener, this hose here. You got 4 bolts and a keyway. 4 bolts bolt the pump onto the motor. The keyway goes into the shaft and the shaft hole of the pump. So that's the first thing I'm going to be doing is putting the pump onto the motor and greasing this keyway. This shaft hole here does have some grease in it, so I take my finger in there a little bit and I grease up this keyway. Here I'm greasing it up a little bit, putting it on there. My head's kind of in the way, but now one of the things I do is I put it on once and then I take it back off again. And then there's a lot of leftover grease that comes out of the shaft. Then I smear that little grease all around the whole shaft, inside the keyway and outside the keyway, to make sure it's all covered with grease on all sides. And basically what that's doing is whenever there's a failure of the motor or the pump, you can get it apart easier after a long period of time. So continue on here. Putting the screws in. Now this next sequence of videos is I'm installing the pulsation dampener. That's the first thing that's going to come off this regulator here. Here we have the pump, and there's a piston in here that goes back and forth, and this is a pressure regulator that regulates the output pressure that comes out of the pump. Since this is a positive displacement pump, that means there's a piston in here, plunger, that moves back and forth. It pushes water at a high pressure out of this the outlet here. There's pulses. When you push water, it pulses. So there's a bit of vibration that happens in the output hoses and lines that go out. So what this hose does is expands and contracts a slight amount when this piston goes back and forth to dampen the pulses so it doesn't vibrate so much. So we'll continue on the video and watch me put this pulsation dampener in. What I'm putting some Teflon tape on a branch T. This is a 1/4 inch branch T that I'm tightening on the actual pressure regulator itself, and now I'm putting the pulsation dampener in the top of the branch T. So attaching that. Now I'm putting on another branch T, but actually this is a mistake. I shouldn't have put this branch T on there, and you'll see that here shortly. I'm taking it back off. I needed a little more room for the gauge, so now I'm putting on a nipple and then actually just a regular T. And you'll see here shortly I'll be putting on this gauge here, and it'll fit on there and not run into the hose, which the other branch T would have done. So tighten it up good. Alright, so now what I'm doing here is actually doing a little bit of wiring. The pump itself has what's called, I guess, open wiring, that you can do a lot of, you can open wire it to some terminal blocks or a contactor or whatever. It doesn't have a cord on it. So, and then it's configurable for a lot of different voltages. But we're going to be configuring it for 120 volts, putting this plug on it right here. So what I'm doing is configuring the wiring. Basically, I'm going to get the wires. There's 6 wires total here, and a 7th is a ground, that green one right there. But I'm going to get the wires configured, then I'm going to solder them 3 wires together with the soldering gun and a little bit of solder here to get the 3 wires and 3 wires, the hot and the neutral, together, so I can put the plug on. Then I'm also going to put this shrink wrap on there to make it look like it's basically a cord. So here we go. So this cord ends up being like only about a foot long, but it's enough to get it out a little bit and then put an extension cord on it. So, and this is the plug again that's going to go on there. So you can see that we've got 2 sets of wires and a ground, and now I'm putting the shrink wrap on there and pushing it down. Actually, the shrink wrap was just a little bit small or tight for the job, but it got down there. And then I use the heat gun to actually shrink the tubing a little bit. Turn back some wires, turn back some of the shrink wrap tubing, and install the plug. Now what I'm doing right here now is actually tightening down the motor. These bolts here are Allen head bolts that I did not tighten them down. I just finger tightened them, and I've got my Allen set out here, and I realized that it's actually metric, so I got another Allen set out here. It didn't work, so here's my metric set over here, and I think it's 5mm Allen hex head. Okay, what we're doing now is installing a branch T off the inlet. Now the inlet's 3/8 inch here, so we've got a 3/8 inch branch T going in here. And what we're going to do is build a little bypass around this. Here's the bypass for the regulator right here, so we're actually going to come back into the input. So continue on here. Tying up the pulsation dampener into a circle with some wire ties, so it's kind of in place. Now this is installing the first part of the bypass, water bypass, and this is a 90-degree barb fitting to 1/4 inch NPT. Tighten that up. Now, the next thing I'm doing, I'm not quite finishing this up yet, but you can see that right here I'm installing a check valve. And this is a very important step. This check valve is going to go off of the discharge of the pump. And we'll continue on here. And this check valve, as you can see, I put a nipple on there first, and then this check valve. It does have a couple arrows stamped in the check valve. It happens to be a female 1/4 inch check valve, so there's a particular direction for it. Now this check valve plays a very important role. It's needed to keep the high pressure liquid, the high pressure water, in the high pressure line when the pump shuts off. And then that bleeds down through the nozzles, that the small orifice in the nozzles. And sometimes with a long line you can have, it takes a while to bleed down. Now when I said this is very important, it's important because if you didn't have that in there, as soon as the pump shut off, high pressure would go back this way, and actually high pressure would actually go back through the pump and into the inlet of the pump and cause the inlet water pressure here to rise. Say if it's city water here, that's kind of a no-no to have additional water pressure pushing back onto the inlet. And then as the nozzles bleed down, because if you had a gauge on here, I don't have a gauge on here, you'll see that gauge spike up to 100, 150, 200 psi, depending on some variables, and then slowly bleed back down as the nozzles bleed. So this check valve is very important. You know, and that could get into, you know, it's worth at this point to discuss some other options that do go on to pumps, and those other options are there to prevent, you know, further failure or further safeties within the pump. Now let's just take for an example, say all the nozzles out here in the line plugged up. No, excuse me, yeah. Let's say this check valve failed here and wasn't checking it off. Well, then you're going to have this high pressure water going back this way. Sometimes what gets put on these systems is a relief valve. So right in here you'd put in another valve that would relieve the water to the ground, basically. This regulator is a relief valve also, but it's being piped back to the input. So let's say this regulator failed and was not relieving any water back to the inlet, and this causes the pressure to rise here quite high, you know, 1500 psi or so. Then you'd have a regulator in here set to 12 or 1300 psi that would relieve the water out of it. So there are other, you know, options that can go onto these systems to make them more reliable, I guess. It's probably not the right term, but more safeties on them. The other safety that gets installed sometimes is a bypass temperature sensor. So here we'll install a bypass, and if someone, the example of that is someone, your nozzles all clog out here, or somebody has a valve off the outlet of this pump and they shut the valve off and the pump is running, you're going to bypass water all the time through this pump, and that water will heat up and eventually it'll destroy the pump because it's looping around in a circle and you're not providing any more cool water to cool the pump down. So what they'll do right on the inlet back into the pump, they'll have a temperature sensor that actually will open up the water. It's a thermal sensor that will open up the water and discharge the water out if it gets to 130 or 140 degrees. So those are just two other safeties that can go on to these systems to make them, again, more safe. But if this is a monitored system, where you're monitoring it all the time, you only run it periodically, and you're always kind of watching it, it's fine the way it is. But if it's a system that's going to sit there and run continuously with knowing watching it for a long period of time, those safeties are worth putting on. So, and that brings up another point, is that this CAT pump here, this pump and motor, is a continuous duty pump and motor, meaning that it can run all the time. You'll run across some pumps and motors, high pressure pumps and motors, that are really not rated to be continuous duty. This one happens to be rated. It can run all the time. So we'll continue on with this video. Again, installing that check valve in there, tightening it up a little bit more. Now we're installing the other 90-degree barb to NPT fitting, and then looking at the hose that goes in there. Actually fitting the hose with a couple of hose clamps. So here it's complete now. You can see that there's just this is a 1/4 inch piece of rubber hose. It's kind of a high pressure hose, probably good for 125 to 150 psi. But this is not, when it does bypass here, this is a 1000 psi water pressure here. But when it comes out of here and does some bypass, it's at low pressure. It's at whatever the city water pressure is. So this pump has the capability of putting out a ½ gallon a minute. If you only need a 1/4 gallon a minute at 1000 psi, this will regulate it back into the input and circle it around. As long as there's a little bit of water coming in to this side to cool the pump down, this circulation is fine. So that's how we actually regulate the pressure out of the pump. There's a little nut with an Allen head here that actually is adjustable to adjust the pressure on this gauge right here. This happens to be a 3000 psi gauge. It's a little high because we're only running in between 500 and 1000 psi, but that's fine. So that's where it happens here. Now the other thing is, here's a filter that goes on the input, and I'll show very quickly how that would attach onto the input. If you needed a small little filter, that's a mesh type stainless steel mesh 80 mesh filter. And then there are a couple other fittings that I included in this package, and that is this. This is a 3/8 compression fitting that can go on to the input side, and then right here there's a 1/4 inch compression fitting to NPT that can go on the discharge to get the lines, connect some plastic lines onto it. So plastic lines or solid copper or stainless steel piping. So I'll run the video here. There I'm showing the filters and the lines. And basically that's it. That's the end of the video. I'm going to box this pump up and ship it out to the customer. It actually will fit in the box that it came into. That's why I didn't attach a couple of these fittings, is that I can slide this right back into the box, put these fittings in the box, and away we go. If you're interested to know how this video is put together, I used a GoPro camera, GoPro 3 camera with time-lapse photography. That GoPro, that's what gives it its fisheye type look here. But it's a very good camera for doing time-lapse photography. And then I use Cinema 2 video capture software, and then this is done on a MacBook Pro. So just a little bit more information for you about how this was put together. That's it for now. Thanks for watching, and I'll see you in the next video.